Hello guys, welcome to all of you on my YouTube channel. This is Samadan Kale. So guys, in this video, we will learn the practical number 9 of the third year BSc Mathematics of subject Python programming. So this is the practical 9 guys. Before starting the today's video guys, if you do not subscribe to my channel, please subscribe it and press the bell icon so that you will get the latest update of videos like of this. And please guys, like the video. So let us start the today's video. So this is the practical number 9 and which is application of eigenvalues and eigenvectors. Okay. So how we can use this application of eigenvalues and eigenvectors, and this practical is based on unit number 4 of the point 4.6. Okay. So let us take the first question. What is first question? Explain the diagonalizable matrix and is a diagonalizable function in Python with suitable examples. So firstly, we have to give the diagonalizable matrix. Okay, that is what is a diagonalizable matrix. So, so I have given the definition. A diagonalizable matrix is any square matrix. Okay, that means a matrix which should be a square matrix or a linear map. Okay, or linear map where it is possible to sum the eigenspaces to create the corresponding diagonal matrix. So this is the definition guys, and n matrix is diagonalizable if the sum of eigenspaces dimension is equal to n. That means if the sum of all eigenspace dimension is equal to the n, then and only then we can say that the matrix A is diagonalizable. So these basics we have learned in mathematics. Okay. So now is a diagonalizable function. This function is in Python. So how we can check it? So this is the syntax guys. A dot is diagonalizable, and in this function the parameter reals only. Okay, reals only equal to false and keywords arguments. So it will return true if the matrix is diagonalizable. We will get the output in true and false. Output should be in Boolean. So when we get output true, when the matrix is diagonalizable, and if the matrix is not diagonalizable, we will get the output as false. Okay. So here the parameters are in detail. Reals only. This is the bool optional. If true, that means if it is a true, it tests whether the matrix can diagonalize to contain only real numbers on the diagonal. Okay, so it will check. And if the false, it will test whether the matrix can be diagonalized at all, even with numbers that may not be real. So this is the parameter guys. So reals only if it is a true, and if it is false, then what will happen? Okay, now I have given the example here. So this is the example from simply import the matrix, and I have defined this matrix 3 by 3 matrix, and these are the entries of the 3 by 3 matrix. Okay, and now I am using this function a dot is diagonalizable. Okay, and if I run this, so I will get the output as true. That means the matrix A is diagonalizable. Okay, so it will take some time. Yes, it's a true. That means the matrix A is diagonalizable. Now, let us take the second question. Next, move to the second question. So what is second question? Find the P and D for the matrix if A is diagonalization. Yes. So we have to find the matrix P and D. So guys, how we can find the matrix P and D? That means we have to find the upper triangular and the P matrix and diagonal matrix. Okay, so that it will written as the P into D into P inverse. The matrix A can be written in the form P into D into P inverse. Okay, so let us take first import the simply or from simply. Okay, from simply we have to import the matrix. Okay, so matrix, and then you will write the matrix A is equal to, okay, this is a matrix and which is of 3 by 3 order. Okay, and then you have to enter these numbers 1, then 2, again 2, then 2, 1, and 2, then 2, 2, and 1. Okay, so this is our matrix A. Now we have to find the P and D. So I'm using P comma D is equal to, okay, A dot diagonalize. Okay, A dot diagonalize. I am using A dot diagonalize. So what it will be written, guys? Let us see. It will return the tuple PD where D is diagonal, and this D can be represented as P inverse M into P. That means the M matrix can be represented at P into D into P inverse. Okay. So these are the parameters, reals only and square D normalized. So if we run this, so it will be run. Now I want a matrix P, guys. Okay. So I'm using P here. Let us run. So I will get the matrix P. I will get the matrix P. And if I use this D, matrix D, so I will get the matrix D. Okay. I will get the matrix D. Now I want to check. I want to check whether this A matrix is equal to P into D into P inverse. Okay. So I will use this P star D into again star and P inverse means double star minus 1. Okay. And let's run it. So it will calculate the matrix multiplication P into D into P inverse. Okay. P into D into P inverse. Now I will check whether this equal to A. Okay. So I will take this one. So control C and this equal to capital A, and let's run it. So I will get false. I will get false. So guys, this matrix is not diagonalizable. Is not diagonalizable. If I check here, if A is a diagonalization, then we have to find the P and D. Okay. So if I want to check whether this is diagonalizable or not, so I will add here one comment. Okay. So I will use A dot, okay, is diagonalizable. So where it is diagonalizable, and let's run it. So I will get true. I will get true. 1 second. It's run. Yes. And it's again true. Yes, it's the true. If it is a diagonalizable, then we have to find the P and D. So this is our matrix P and matrix D, which is D, this minus 1, 0, 0, and 0, 5.2 minus 30, square root 33 upon 2, 0, and this one. Okay. So this is the diagonal. And this is product P into D into P inverse that we have calculated. And it is not equal to A. Okay, this is not needed for you. P into D into P inverse. Okay, let's cut it. So you will not write this one. Okay, you have to find only P and D. Now same I will use here. Let us move to the third question. Next, third question. So find P and D for the matrix if A is diagonalizable. So firstly we have to check if A is diagonalizable. Then we have to find A, P and D. So let us take this from simply import matrix. Okay, import matrix, and then I will use this one. What I will use now, matrix A is equal to, I'm going to use this matrix, and in this one I have 3 by 3 matrix, and I will run this 1, then minus 1, again 1, again minus 1, 1, minus 1, 1, minus 1, and 1. Okay, so this is our matrix A, guys. Now I will check whether it is diagonalizable or not. So A dot is diagonalizable. Okay, A dot is diagonalizable. Okay, and let's run it. So it will be true. Now we will find P and D. We will find P and D. So I'm using this P comma D is equal to this A dot diagonalize. Yes, A dot diagonalize and give the parenthesis. This diagonalize is small. Let's run it. So it will be run. Now if I want P, so I can get this P1. Okay, and if I want D, I will get D also. So in the next cell, I will write as D and let's run it. So we will get D also. Okay. So this is the third question. Next, we will move to the fourth question. What is fourth question? Find P and D for the matrix if A is diagonalization. Same question, guys. Okay. Now I will copy some code here. Yes, this code I want to copy. Same code. And I will paste now into the fourth question. Now instead of this, I want to replace these elements by this one. What? 1, then minus 6, okay, and 3, then again 3, then minus 1 and 1. Last one is minus 1, then 9 and minus 1. Okay, this is our matrix. So if I run this, so it will give me some output in true or false format. Okay, let us wait some time. It's running. If it is a true, then we have to find P and D. So for that, we will type in the next cell P, then D is equal to what we have written, A dot. Yes, it's a true. That means it's diagonalizing. A dot diagonalize. Okay, diagonalize. And let's run it. Okay, if you want, you can take here itself as P also. Okay, as P also, and then run it. It will take some time. Okay, because this file is very big, that's why it's taking time. And if you want the matrix D, you can give D here and run it. You will get the matrix D also. Okay, just a second, it will be running. You will get a matrix P and D both also. Okay, so let us move this one. Let us see. This is the matrix P, guys. Okay, this is the matrix P. Here you have to remember this is matrix P. Okay, I will move this one. Okay, pause the video and write. This is your first entry. Okay, this is first element. Which is first element, guys? This is first element of the matrix. Okay, now second element. Okay, first column, second element, and third element. Third element is 1. This one. Okay, yes, pause the video, write this one. Now next second column is what, guys? This one. This one is your second column. Okay, from 4096 to here. Okay, and this one. This is your second column, guys. Up to 1, not this one. Okay, this minus sign, not this one, not this one. So pause the video and write this output. Next one is, what is next? This is the third column from the minus signs. Okay, this is your third column. Pause the video and write the output. Okay, I hope all of you understood this. And if you want D, you can check D also. Let's run it. You will get the matrix D. Okay, so D is a diagonal matrix. Okay, so this is the diagonal matrix. Pause the video, write this one also. This is the diagonal matrix, guys. Write this one, and then you have to write this one. This completes the matrix. Okay, pause the video and write it accurately. So this is first one. Okay. Let us move to the next question. Last question, that is fifth question. Okay. Same code I'm using, but here what I have to do, using the Python, decide whether the matrix A is diagonalizable or not. We have to check only this matrix is diagonalizable or not. So firstly, I will give the elements as a 2, 1, 1, then 0, again 2 and 1. Okay, then 0, 0 and 2. Let's run it and it will give me the output false. That means we don't need to find P and D. Okay guys, I hope all of you understood this practical number 9 of the Python programming. So guys, write these outputs very clearful. Okay, so thank you for watching the video.